Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal for Spectroscopy in Chemistry. This is lecture number 37. In this lecture also I will explain you numericals related to Diene system. So first of all, let us take this numerical. Here we have double bond, then double bond, double bond, double bond and double bond, all are in conjugation. Okay, so first of all we'll have to consider the system, and you can see all double bonds are, or any two of these double bonds are not in one ring. That means homoannular Diene system is absent. Now second is heteroannular. Here you can see these two double bonds are in different rings. Even these two double bonds are in different rings. But here one double bond is out of this ring, one double bond is inside the ring, and it is called acyclic or non-cyclic or open chain Diene system. For heteroannular Diene system, the base value is 214, and for open chain Diene system, we have base value of 217. So our main system become open chain Diene system or acyclic Diene system. Why? Because its base value is more. Okay, so here our main system is acyclic or non-cyclic Diene system, and for that base value is 217 nanometer. Okay, so that we'll consider this, right? Now which one is having it has extra conjugated double bond, so we have to include those in the system. So we can extend this system from here to this double bond, even single bond, and then double bond and single bond and double bond. So these are extra conjugated double bond in system or extended system. So extra conjugated double bond. Now how many? 1, 2 and 3. So for each we add 30. So for 3 we will have to add 90 nanometer for this one. Now next one we'll have to see exocyclic double bond. So exocyclic double bond. So first of all, this double bond, let us give the names or numbers to this ring: A, B, C and D. Now the first double bond of the system is this one, and it is exocyclic for A ring. So 1. Now second double bond is here, which is exocyclic for B ring. So this is also exocyclic. Third double bond is here. It is in B ring, but it is exocyclic for and this is a part of this extended. I made a mistake over here. So here we'll see that in B ring, this double bond in B ring is exocyclic for A as well as for C. So we'll consider twice this one. Now this double bond which is in C ring is not exocyclic for any one of this, because both carbons are in this ring only. But the last double bond over here, which is in D ring, is exocyclic for C ring. Here there is one more ring, but there is nothing in this ring, and it is not in their system, so no need to take this into consideration. So number of exocyclic: 1, 2, 3, 4 and 5. So 5 exocyclic double bonds, and for each we take 5, so total 25 nanometer is added. Okay, next is substitution. So first of all we'll take RR, ring residues, taking from here. The first RR is this one, or we can just put the line over here. So this is one RR. Then for second carbon this is RR. For third one nothing. Fourth one is this one. For fifth one, this one will be RR. Next is this, so this will be RR. Over here, nothing, and then here, this is RR. For this one, we have this RR, and for the last one, we have 1 and 2. Okay, so number of ring residues 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 into 5, 45 nanometer is added for ring residues. Anything else? Any kind of substitution? Well, OH group is present over here, but this group is not attached to the system carbon. Therefore, we do not consider this one in the total calculations. Okay, so nothing is left over here. Now we have to find out lambda maxima for this one. Okay, so make a total of this and find out lambda maxima value for this compound. Next one is this one. Here, first of all, we will take system. Again, one double bond is in the ring, but another is outside the ring. So we will have this one is as a system, and it is open chain or acyclic system. Okay. Next one, is there any double bond in the extension? Yes. So there is, this one is also in extension. So we'll consider this one. So first of all, we will take acyclic diene system, and for that we will add base value 217 nanometer for this one, for this system. Now extra conjugated double bond present or not. So for extra conjugated double bond, we will take one double bond is extra. So 30 into 1, which is will be 30 nanometer for extra conjugated double bond. Okay. Now next is exocyclic double bond. Now give numbers to each carbon of the system: 1, 2, 3, 4, 5, and 6 carbon. So there are total 6 carbon in system. Now check each double bond. So first of all, the double bond is between C1 and C2. Is it exocyclic for any other ring? Yes. Why? Because there are two rings, A and B. Look at this bracket. This bracket indicate ring. Okay, so we will consider here as a ring, and therefore C1, C2 is exocyclic for B ring. Why? Because C1 is, sorry, not for B ring, but for A ring. Why? Because C1 is in A ring, but C2 is not in A ring. That's why it is exocyclic for A ring. Okay. Is there any other exocyclic? Yes. C3, C4. C3, C4 bond, which is exocyclic for B ring. Why? Because C3 is in B ring, but C4 is not in B ring. C5, C6 is not exocyclic. So there are total 2 exocyclic double bonds. So 2 into 5, we will take 10 nanometer for exocyclic double bonds. Now next is substitution. So we will take ring residues from each one. So let us take C1. This alkyl group will be ring residue for C1. Even this alkyl group is ring residue for C1. With C2, nothing is attached. So, but of course, there are 2 carbons, C1, C3 with C2, but both are the part of system. So, we will not take any as ring residue. C3. C3 has this carbon over here, which is ring residue. For C4, this carbon is there, so ring residue. For C5, this is a functional group attached to this C5, so we will consider this. With C6, this one is a ring residue. Remember, NC2H5 twice are not the part of rings, so do not consider them. These are not in the ring. So total number of ring residue, calculate 1, 2, 3, 4, and 5. So total 5 ring residues, and therefore we will add 25 nanometer for this ring residues. OH group is present but not in the ring, not in the system. Cl is also not attached to the system. AACO or OAC, or that is OCOCH3 group, which is in the system, and for that OCOCH3 group we are adding 0 nanometer, and therefore we'll take 0 nanometer, and this way we have to calculate. Anything else left, just check it. It is a cyclic diene system or non-cyclic or open chain diene system, because one double bond is in the ring, one is outside the ring. So for that, base value is 217 nanometer. Extra conjugated double bond is 1, therefore we take 30 nanometer for this. This C1 C2 bond is exocyclic for A ring. C3 C4 double bond is exocyclic for B ring. So total 2 exocyclic double bonds, 10 nanometer. Then substitution ring residues 1, 2, 3, 4 and 5. So 25 nanometer for that. For OAC substitution we take nothing. So total of all this will be lambda maxima. That will be the absorption wavelength of this compound. So this way we can calculate lambda maxima for this system. Thank you so much in this lecture.